Hello everyone, welcome back. Today we're going to be talking about a topic that I really like to talk about, and it's positive and negative feedback. Right? Not the kind you guys give me in my comments or anything like that, but we're going to be talking about positive and negative feedback from a biology perspective. And specifically, we're going to talk about the perspective of endocrinology. So this is going to be more of an endocrinology lecture than anything else. Once again, guys, we're coming up on a new year of the MCAT lecture series. So there's a brand new emailing list. It will be the first thing linked down in the description below. If you guys would like to keep up with updates about the lecture series and things that I'm doing, please go sign up to be part of that emailing list. Thank you so much. And there you will also find links to the lecture drive folder where I put all the resources for the lecture series. And you'll also find links to my Buy Me a Coffee page and my Venmo. If you feel generous enough to donate to the channel, you can do so. And 50% of all donations go to charity. By the way, I have homework for you today. If you have a friend who's studying for the MCAT, just tell them about my channel so it can help them out and it'll help me out. Thank you guys so much for your continued support. Let's get right into it. So let's talk about the HPTA axis, or I guess the A stands for axis. So I guess the HPT axis, right? The hypothalamus, pituitary, testes axis, right, inside of men. So the HPT axis starts in the hypothalamus for H. And when a man who's either going through puberty or has already gone through puberty produces the specific hormone called GnRH, right, which is gonadotropin releasing hormone, right? What does gonadotropin mean? Well, it means that it's tropic to the gonads. Now, what does tropic mean? Well, let's go over what tropic means, right? Well, if A tells B to do something, and then B tells C to do something, and C does the thing, then what? This is a tropic effect. A has a tropic effect, B has a tropic effect, C has a direct effect, right? So B is tropic on C, and C has the direct effect, right? So when we say gonadotropin, there's something that is tropic to the gonads, right? So let's say these are our testes. Something is going to come and act on the testes, and the testes are going to release something that does the work, right? So let's see how that works. Right. So gonadotropin releasing hormone. So that means that this hormone, GnRH, is going to release things that are tropic to the gonads. So it's not even direct in and of itself. It's tropic to the thing that's tropic to the testes, right? So GnRH is actually going to signal for, so this is going to signal for LH, which is luteinizing hormone, and FSH, which is follicle stimulating hormone, release from the anterior pituitary, right? So GnRH is going to act upon the anterior pituitary, and it's going to release FSH and LH. And as I said, these guys are from the pituitary, so that's the P in HPT, and then they're going to go and act on the gonads because they are tropic to the testes. So they're going to act on the testes, and the testes are going to release, of course, testosterone. Quick question as a quiz for people who are studying for the MCAT. Which one of these is responsible for releasing testosterone? Give you a minute. Wish I could get the Jeopardy theme playing while you're thinking. Do you have an answer? Well, it is luteinizing hormone. Luteinizing hormone is going to come to the testes and trigger the release of testosterone. How do I remember that? Well, I know that follicle stimulating hormone actually produces the release of estrogen in women, and I know that it's backwards in men. So the LH is going to release the testosterone in men. And what does the FSH do in men? It codes for sperm production, right? So this is called a tropic effect, right? Where LH acts on the testes to release something that has a direct effect. And the gonadotropins are these two guys, and they were released by gonadotropin releasing hormone, right? That makes sense. So this guy is like double tropic to the testes. It releases something that causes it to release something else that does the effect, right? Okay, so this is the HPT axis. Why am I talking about all this? Well, it's because this all kind of relates to the idea of negative feedback. The testosterone that's produced here is going to come and inhibit the GnRH release. It's going to decrease all of that. And that makes sense. Well, let's kind of look at the goals here, right? What are the goals? Let's say that in a factory, my goal was to make C, right? And I hired this many workers to make this much B, and that much B makes this much C. So this is like the middleman, right? If C is being made, right, and have enough of it, these workers can stop working until the amount of B goes back down and the amount of C drops. So I need them to start working again. But as long as enough C is around, we can get these workers to stop working. So as long as enough testosterone is around, we can actually come back and shut down the whole system, turning off the GnRH. That's negative feedback. What is one of the only examples of positive feedback that you need to know? What is it? It's actually the one related to oxytocin, and it's one of my favorite things to teach about as well. So when a woman is pregnant, right? The woman is pregnant, she's just about to give birth. So there's this huge baby inside of her, and that's what we're going to draw for the baby, because I can't draw a baby, right? There's something known as the cervix, and the cervix is just what leads out of the uterus and into the vaginal canal. So the baby presses against the cervix, and the cervix dilates. That cervical dilation leads to the release of oxytocin. Oxytocin is this huge compound, absolutely massive. And it's also known as the cuddle hormone because it gets released when you do a loving act with a pet or a friend or a significant other or a parent or whatever. Like anything you do that's comforting and loving, oxytocin gets released. But that release of oxytocin actually acts on the uterus to contract the muscles. And that muscle contraction pushes the baby down lower, and that leads to more cervical dilation, which leads to more oxytocin, which leads to more contraction, right? So cervical dilation leads to oxytocin, leads to contraction, leads to more cervical dilation, more oxytocin, more contraction, more cervical dilation, more oxytocin, more contraction, until the baby passes through the vaginal canal, the birth canal, right? And then finally when the baby's gone, this whole thing stops, right? But then the mom is left, so over time, this is the amount of time, and this is oxytocin, this is the amount of time, and this is oxytocin, right? It's just going to steadily go up, 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 and it's going to plateau out, and then it's going to slowly fall back down. So you can see at the time when the baby is born, the oxytocin is very, 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 very high, and this is a hypothesized reason why mothers and babies have a bond immediately, because the oxytocin, the cuddle hormone, the love hormone, is so high inside the mother when she gives birth. So that's a little overview of positive and negative feedback mechanisms. It wasn't like an official lecture or anything. It's just something I wanted to talk about because I like talking about it and it's interesting to me, and this is what I'm passionate about, and this is what I love to do with my life. So if you guys liked that video, please be sure to drop a like, subscribe to the channel. Thank you guys so much. I really appreciate it. And yeah, I'll see you in the next one. Bye-bye.